Hi everyone, welcome to part 2 of our chemistry review and intro to properties of water. In this video we're going to focus more on the properties of water. Remember in the last video you should have watched part 1 before you're watching this part. We went over the structure of water along with some of the chemistry from last year that's going to be applicable to bio this year. In this video we're going to have two main objectives. First we're going to be describing some of the properties of water and relating it to its polarity. And then we're going to specifically talk about how some of these properties are involved in regulating the temperature of organisms. Okay, so before we move on, I want you to take a minute and think about all of the properties of water that you've learned in your past classes. This is a topic that you've probably covered in elementary school, middle school, and maybe even a little bit in high school in chemistry last year. So I want you to take a moment and come up with a list of properties that you remember. Okay, so some of the properties we're going to go over in this video are cohesion and adhesion. We're going to talk a little bit about specific heat and how water's specific heat is relatively high. We're going to talk about how it has a high heat of vaporization. We're going to talk about why it's a good solvent and why that is good for biological systems. We're going to talk about its density, and we're also going to talk about how it interacts with nonpolar molecules. So we'll talk about a little bit about each of these different properties, and you want to make sure that you can come up with a biological example of how water's properties influence organisms. So let's talk about cohesion and adhesion first. Now when I think of cohesion, cohesion is really the attraction between two water molecules. So we can go back to what we talked about in the last video with the polarity of water. So you have a negatively charged oxygen and positively charged or partially positively charged hydrogens. Now we talked in the last video about the attraction between them. What type of intermolecular force is going to form between the hydrogen of one water molecule and the oxygen of the other water molecule? That's right, hydrogen bonds. So we know that hydrogen bonds are very strong intermolecular forces. They're not actually bonds, but they're holding together these water molecules. Now this is basically what cohesion is, the ability of water to attract to each other and to hold on to each other. And because of that, it's going to have some unique properties. For example, if you drop a single drop of water on a surface, it's going to form a droplet. This isn't the case for most liquids. If you do the same thing with rubbing alcohol or even acetone in nail polish remover, you're going to see that when it drops, it's going to flatten out. That's due to the high surface tension of water. An example in biology that we'll talk about is bugs that can walk on water. Now, if water didn't have a high surface tension, this bug would fall straight through the water and not be able to land on top of it. But here in the diagram, you can see the water is almost bending underneath the weight of the insect, but he's not falling through, and that's due to the high surface tension. And the high surface tension is due to these hydrogen bonds between the water molecules. Now, is this such a strong attraction that you can't break those hydrogen bonds? Of course not. Otherwise, we would be walking on water. But light insects can stabilize on top. Now, adhesion, the way I like to remember the difference between cohesion and adhesion is I think of adhesive tape. Something that's adhesive is going to stick to other things. So what types of molecules or surfaces do you think that water molecules are going to be good at adhesing to or sticking to? It's going to be able to stick to polar surfaces. Now that's because likes dissolve likes. If this polarized molecule is only going to be attracted to another charged surface. So a great example of this would be capillary action in plants. So basically with capillary action, if you put a small tube in a thing of water, you'll see that the water climbs up the side and is able to stick to the sides of the tube. And this happens in plants and is one of the driving forces for how water goes up a stem. However, we'll talk later this year about another major driving force called transpiration, which is going to influence it a lot more than capillary action. But that attraction for water to the sides of the stem is still going to be important for getting that water up to the top. All right, so we have a thought question. Why does our body temperature remain relatively stable regardless of the temperature of the environment? And take a minute to ponder and think about this. And this brings us to another property of water. So if you remember, our body, there's a couple different ways you can actually go about this thought question. You can say that we're homeotherms and that we regulate our body temperature regardless of our environment, which is true. Not all organisms do that. So like reptiles can't do that. However, we can also tackle this question if we think about what our body is composed of. So our body, we said in the last video, is composed of about 2/3 water. Now, water also has a very high specific heat. If you compare it to other substances, liquid water has it will take about 4.18 joules to raise a sample of water just 1 degree Celsius. Now, if we compare that to some metals like iron, copper, and lead, this is significantly higher. It's much more difficult to heat water. And you know this if you've ever boiled a pot of water. You put a pot of water on the stove, the metal pot is going to heat up quickly, but the water inside it takes a lot more energy in order to heat it up. Now let's relate that back to our body. If you stand outside on a 100-degree day, the liquid in your body takes a lot of energy to heat up. Now, will your body, if you stay out there long enough, heat up? Of course, but we have other mechanisms within our body to maintain that constant temperature. But the key here with the high specific heat is that it won't heat up quickly. Same thing goes for losing heat. It takes a decent amount of time before water loses heat as well. Now, this also influences fish. So if you think of a lake or a pond near your house, perhaps, on that 100-degree day, is the water 100 degrees? No, of course not, because it has a high specific heat. So it will warm up on a warm day or over the course of a summer. However, it doesn't warm up fast. It warms up pretty slowly. So organisms like fish that live in aquatic environments are able to have more of a constant, stable temperature. It doesn't fluctuate with the temperature of the day. So during the day, the water will be about the same temperature as at night, and it will heat up and cool down very slowly, which is great for fish. Now let's say that we were a marathon runner and we were going for a run because that seemed like a good idea. What is one mechanism that the body uses to dissipate heat created from your body doing work? So as you run a marathon, we're going to talk about this a little bit later, but your cells generate a lot of heat as they do work. So what's one way that your body uses to get rid of some of this extra heat? So when your body has too much heat, you will start to sweat. And basically what happens is your sweat glands produce moisture and that comes out to your skin. I'm sure this summer, with it being so hot, you have experienced this. And then what happens is the water is going to evaporate off of your skin. Now, as the water evaporates, it's going to pull extra heat with it. Water has a very high heat of vaporization. So because it takes a lot of energy to vaporize water, to turn it from liquid water into vapor, as that happens, the water is pulling that extra heat with it, making you feel cooler. This is why standing in front of a fan on a really hot day makes you feel cooler, because the sweat is evaporating off of your skin and pulling the excess heat with it. So this is another reason why you maintain a constant body temperature when your body is too hot. Now remember, not all organisms can do that. That is specific to humans with the sweating, but all homeotherms have some way of dissipating that extra heat. Okay, another property of water is that it can organize nonpolar molecules. So we know that water is polar, and we know the rule likes dissolve likes, meaning only polar things are soluble in other polar things. So this picture looks complicated right now, but I promise you in another couple weeks you will 100% understand this diagram and think that it's very simple. So for right now, we're going to focus on two things: these little hydrophilic heads and these little hydrophobic tails. Now this is a cross-section of a cell membrane. So these separate or divide up your cells. And this would go all the way around your cell. We're just looking at one little section. Now on the outside of the cell over here is a liquidy material, and inside your cells is also a liquidy material made mostly of water. So basically what happens, the hydrophilic heads of this are attracted to the water because they're soluble in one another. But why do we see all of these tails in the center? Well, just like when you put oil with water, they can't mix. So basically, because of the different properties in the cell membrane, and because water is polar, it forces these non-polar parts to avoid the watery outside and inside of the cell, forming that beautiful layer around your cell, separating the inside of your cell from the outside of your cell. So don't forget about the rule, likes dissolve likes. Polar things will be soluble in other polar things. So anything polar or charged will be soluble in water. Okay, this also leads to why water is such a good solvent. So water can easily dissolve ions because ions are charged. So if we look over here, NaCl, we talked in the last video, is ionic. So when you put it into water, so if you have it as a solid, it's going to be the Na and the Cl will be bonded together. When you put it into water, it does something called dissociates. That means it just breaks into its ions. Now what happens when you put NaCl in water, the positive Na is going to be surrounded by the negative oxygens, and the negative Cl will be surrounded by the positive hydrogens. So what this forms is something called a hydration cell, and that's going to keep the Na and Cl from attracting to each other. So it keeps it soluble and keeps it in solution, and it avoids these two from bonding back together. Now this picture, although entertaining, brings us to our last property of water. So take a moment and try to guess which property of water this represents. That's right, ice is less dense than water. Now, this is due to the fact that when ice freezes, it actually expands, which is different. Not all substances, when they freeze, expand. As it does this, it likes to form more of a ordered structure as a solid, as opposed to water, which is more jumbled and the molecules are closer together. Because it is more spread out, it traps air pockets within there, making it less dense than the water form. Now, this is really important for organisms because ice is going to float, and you can think about the polar caps and things like that. Now, this allows ice to melt more easily. If you had the ice sinking to the bottom of the ocean, it would be very difficult to thaw that ice and melt it. So most of our Earth's surface wouldn't be covered in water. But because it floats, the sun can melt that ice, creating a very watery environment on our Earth. Another example of where this can come into play is in a lake or a pond. So if ice was more dense than water and sunk to the bottom of the lake, you would start to fill up the lake with ice. The fish would have nowhere to live. But because ice is less dense than water, it's going to rise to the surface. So you freeze the surface of the lake, but underneath you still have water. That ice also forms a little bit of a barrier for the water so that it retains some of its heat, so fish can live in the pond throughout the winter. So that wraps up our video on the properties of water. I hope that this was helpful. And remember, if you want to go over any of it again, you can rewatch the video.